All right, ladies and gentlemen, welcome back to another round of AP Chemistry Lectures. It's been such a long time. Welcome. Here we go. Today, ladies and gentlemen, we're going to move into the redox land. We're going to be taking a look at redox reactions, and specifically today, we're going to look at identifying the half reactions. So redox stands for reduction and oxidation reactions. It's this transfer of electrons. So you need to know redox reactions involve a transfer of electrons. So we look today at being able to, or you've seen before, being able to assign these oxidation numbers, and you need to understand these oxidation numbers are representing essentially the number of electrons. Oxidation numbers are like a bookkeeping method for us to track where electrons went and where did they come from. So, a couple of terms you will need to know. The first one is reduction. Reduction is a gain of electrons. It is a gain of electrons. The next term is oxidation. Oxidation is a loss of electrons. Oxidation is a loss of electrons. Most of the time, I remember this by remembering oil rig, right? Oxidation is loss, reduction is gain, and we know that we are talking about electrons. I guess you could say oily riggy. It's an oily riggy. Oil, oxidation is loss of electrons, reduction is gain of electrons. But you will need to remember this somehow, right? Somehow you need to remember this. Another one is Leo goes grr. Right? Loss of electrons, gain of electrons. There you go. And so what we're going to do now is we'll take a look at a couple of different reactions, and we're going to label our oxidation numbers. All right? So I'm going to go ahead and write one of them out here for you. All right, and what I'm going to do is I'm going to take a break. I'm going to go ahead and assign oxidation numbers. It would be a really great time for you to pause the video and assign your own oxidation numbers because you do need that practice. All right, and so everything now has an oxidation number. And what we can do, because remember the oxidation numbers are indicative of this false charge. Oxidation numbers are not real, ladies and gentlemen. They are not real. They are a fictitious number based on electronegativity values, such that if we were to separate the compound, these are where all of our electrons go. All right? And so versus a charge is a real charge that occurs because an actual transfer of electrons has happened. But these are fictitious. These are oxidation numbers. And so what we'll do is we'll take a look at, well, the ones that change. We're looking for the ones that change. So I notice, right, SB. So SB is our antimony. So antimony's gone from a +5 to a +3. The next one that has changed is actually our iodine. Iodine has gone from a -1 to a 0. And so we are in the process here, ladies and gentlemen, make that a different color, of now we're able to identify two different occurrences here, right? One species lost electrons, the other gained electrons. Well, imagine going from a +5 to a +3. This is a gain of 2 electrons. And going from a -1 to a 0 is a loss of an electron. Remember, if we lose electrons, we become more positive. If we gain electrons, we become more negative. So this is that mental hurdle you need to get over, that when you're gaining electrons, you will be heading in the negative direction. When you lose electrons, you will be heading in the positive directions. And so now, since we gained electrons, this is going to be our reduction. And since the other one lost electrons, it will be our oxidation. And so now what we can do is we actually separate these out and we can start showing what actually happened here. So now I've written out, and this is my reduction reaction, right? And then I'm going to have my oxidation. I'm not worried about balancing anything else out yet. And I understand, I see the chlorines are different, and we're going to get to that in another installment. Right now, we just want to be able to identify and break out our half reactions. So my oxidation reaction would actually be my Ki, and this is going to go to I2 plus, and this is going to be 1 electron, right? Because I went from a -1 to a 0, even though now I do want to go ahead and put that in there because it did happen twice, ladies and gentlemen. This one went from 1 to 1, so the 2 is okay, but this one went from 1 iodine to 2 iodines. Both those iodines had to lose that electron, all right? So I have a total of 2 electrons lost. All right, okay, so now I've got my half reactions written out. I'm going to do another example with you. So again, steps to this, ladies and gentlemen. Write out your oxidation numbers, right? Look for the one that reduced in charge, and look for the one that that actually became more positive, right? And that's your oxidation, that's your reduction reaction. So I'm going to go ahead and erase this, and then we're going to come back, and I'll have another one here for you. Okay, so here we are back. I've got a reaction here. Again, I want you to pause it, and I want you to go ahead and write your own oxidation numbers, all right? Okay, so we've got our oxidation numbers written up top now. And again, we're just going to look for differences. What actually changed in this particular place? So I see cadmium did not change. Sulfur, oh, there's one. So my sulfur's changed, and then the other one that changed, oh, there's that silly iodine again. And let me actually make that line a little bit further down because I want to draw on it. All right. So my sulfur, what did it do? It became more positive. So it lost 2 electrons, right? So remember, oil rig, oxidation is lost. So this would be my oxidation. My iodine, so again, I see a difference there of 1 electron, and it gained 1 electron. So remember, reduction is gain. So I'm going to come down here. This time I'm going to put oxidation first. So let's go ahead and get our oxidation reaction written out. So I'm going to have CDS. This is oxidation. It lost electrons. So that means my electrons are going to be a product. They're produced plus, and then I'm just going to put sulfur over here on the side. And I understand, ladies and gentlemen, y'all are looking at this. You're going, Ms. Dillon, how did that balance out? We'll get to it. We'll get to it. Right now we're just writing and identifying these half reactions, all right? And then your reduction, I'm going I2. I don't know why that keeps coming up. Get out of here. So I2 going to, and this is a reduction, so I'm going to gain an electron and going to H. Now in this particular case, again, this will be 2 electrons because I end up doing that twice. All right, because I have to get rid of both of those iodines. You see that with the diatomic molecules. The diatomic molecules will look like they're just losing or gaining 1 electron, but it has to occur twice because both of the atoms in that diatomic have to do the same thing there. All right, and so again, written out. I'm going to do another one, put it up here real quick, and then I'm actually just going to do it and solve it out, and hopefully you come up with the same answer. All right, ladies and gentlemen, there's your last equation. It looks like a beast, but what I want you to do, I need you to go ahead and assign oxidation numbers to everything, ladies and gentlemen. Find out what's changing in there. Identify your oxidation reaction. Identify your reduction reaction. Go ahead and do it. Pause the video. I'll solve it out, and I'll pop the answer up on there, but I want you to try this on your own, okay? All right, ladies and gentlemen, there you go. There's the final answer. I've got my iron that was oxidized. I did put 2 electrons here in the half reaction just because if I'm looking at this product, this iron produced, there's 2 of them, so I went ahead and just doubled that and doubled the electrons there. And then the other one was my manganese that was reduced. It gained 2 electrons, and I showed that there. And so hopefully at this point you've got down the fact that you can write the oxidation numbers, find what changes, and identify it as either oxidized or reduced. And that's all you got to do at this point, ladies and gentlemen. If you have any questions, please sure you get them down. Bring them to tutorials, bring them to class. I will see you there.